Okay.
Oh, and
So let's look at, yeah.
one thing I was reminded of about 2 years ago, we had our first extreme cold day, where basically it's minus 20 degrees out to stay home, and that kind of set up us being able to fast transition to what we did for the pandemic. And next week it's supposed to be like minus 20 here.
Wow. Okay.
So I was thinking it would be a nice to, if if we were at the office, I'd be telling you to stay home today.
Hmm. Okay. I'm not sure that, okay. I'm not sure that's a positive message, but yeah. Um, okay. Let's let's understand. Okay, I've got some. Okay, let's first of all understand this phase behavior. Okay. Okay, so what is the basic point? The basic point is the thing. Okay, so in fact, I have a summary thing, which unfortunately I haven't been saving in the usual place, which is kind of bad, but okay, here we go. Okay, only though the phase at the end matters. Okay, so let's look at um, phase representation. Okay, so let's say it's phase followed by state, right? So now, what is the basic transformation? What we want to do is, presumably, is increment the phase by 1 at every time step. Do you agree?
No, it's either
That,
+1 or -1 because 0, 0 is -1, 1, 1, 1, 0, 1 is +1.
but the phase, what does the phase represent?
It's how many extra bits are at the end.
Okay, all right. So, oops, what did I just do there? Um, so what we're saying here is the the sequence is of length n, and it consists of a quotient with quotient of n blocks, right? That will be sampled, whose first elements will be sampled, right?
Yes.
Together with, let's say, p elements that will not be sampled at the end.
Correct.
Will not be sampled, but which define how new elements will be appended, right?
Yes. Hmm.
Okay, so now the natural way to define P is exactly like this. So what happens if we do this? Is this Max's way of doing it or not? So I think,
Yes.
okay, well, let's look up here. Where did we have it? Where did I put it? I thought I had something with for phase evolution here. Am I totally confused? Oh, no, here we go. Here's the phase evolution. Okay, so here, so I don't quite understand what's happening here. So this is saying phase 0 turns into phase 1, phase 1 turns into phase 2. Okay, so for these phases, okay, is this correct? To convert it to this to phase form, right? Now you see there's the squiggle here. That's bad.
Hmm.
It better be the case that this is correct. P elements at the end. So two phase form, this would be 2 SW phase form, right? Did you,
I believe so.
Okay.
I would basically, because basically what Max has done is trying to speed things up by 3, and that's why he did it this way.
Why?
I don't know whether it completely helps doing it this way myself.
Wait. Why did he? Why does it speed it up? It doesn't make any difference. It's just a number.
Right,
What?
because it's a compressing
No,
the
no, no, no,
amount
no,
of
no,
that
no,
needs to be
no, no.
processed.
The phase thing is a good idea, right? What I'm just
Mm-hmm.
dealing with is how do you label the phases? Do you get what I'm saying?
Uh-huh.
Right? And I'm saying it makes more sense to label the phases in this way here. Right? Do you understand what I'm saying? So given the phase,
Yes,
you
yeah,
can work out
I
the length
agree.
of the sequence. Okay. So let's work out then what, what that means in terms of this, right? Do you understand what I'm saying?
Mm-hmm.
Okay. So this is two-phase form in my definition of phases, right? Do you agree? If it's an exact multiple of 3, the
Yes.
phase is 0. If it's 1, 2, blah, 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 right?
Right,
Okay.
right. Mm-hmm.
So now, okay, so from phase form, this is wrong. This is from max phase form, right? The 2 minus p.
Yes.
Okay. So now from SW phase form is just pad of p, right?
Right. Right. Mm-hmm.
Okay. So now here we want a TSSW phase step, right?
Right.
Okay. So now this is what? Phase 0. So what does this mean? This is the phase. I see, the phase and the first of the state. Okay. So phase 0, first of the state is 0. So I believe that, well, you tell me what that does. So first of the state is 0 with phase 0. What's the correct transformation here?
I'm not sure.
Oh, come on. Look. Okay, so then what we need to do here is, okay,
I need to write out a chart, otherwise I'll do this wrong.
okay, well, TS pattern evolve of 0 blank blank 1. Okay. So I'm going to write a chart out, which is, okay, so here we say table
So this is a good thing to do if we generalize it. And one thing I'm wondering is, how do you pick out what the phase is for a different tag system? How did we decide on phase 3 for this one? Because it was between 2 and 4?
No, because it's chopping off 3 bits at
Oh,
one
right. Mm-hmm.
step.
That's right.
Okay. Okay, so here we go. So this is, look at this, okay? This is what each, okay? So can you see this?
Uh-huh.
Okay, so then what I think we need to do is we need to ask the question, if you reduce this by blocks of 3, right?
Yes.
What gets put at the end? You see what I'm saying?
Yes.
So this one, I claim 0, 0 goes to null string, well, phase 2 null string. Do you agree? Right? You see why that's doing that?
Let me. Yes.
Okay, so I claim
Mhm.
0, 1 goes to, now let's see, what do we want to do? We want to know the first element of, so I claim that goes to 1. I'm sorry, so phase 1, first element 1. Do you agree?
Mhm. Yes.
Okay. So in general, what we want to do here to find out what we go to is we want to say the length of the thing mod. So, okay, TS pattern evolve. What we want to say is mod hash mod of length of hash, comma 3, comma. Now we want to get the first element of. So what do we want to do? We want to get. Do you understand what we want to do? We want to get the first element. So we want the quotient. But what is the number of the first element that is in the unfinished multiple of 3? Right. So what we
Right.
want to do is we want to say quotient remainder, if I'm not mistaken,
Mhm.
of the length. So we want to say the element that is at. Okay. So let's imagine we got quotient remainder of the length. Let's say this length here, comma 3. Oh, fluffle. Quotient remainder of the length there, okay, is 1, 1. So we want
Mhm.
quotient remainder times 3, comma 1 times that, and we want the total of that, if I'm not mistaken. Right?
Sounds right.
Okay, so then we want to say, I want to put that in there. We want to say hash of this. Okay, then I want to flatten this. That doesn't seem right. Oh, wait a minute. This quotient remainder here, I don't think this quotient remainder thing is right. Do you see what I'm saying?
Okay.
Well, you tell me whether it's right. I mean, I think it's not right. I think that
I usually try to do everything in mod myself.
no, but look. Okay, so let's look at these. Okay, so the first one here says it's 2, comma 0. Is that right? It is right according to these rules.
Mhm.
See what I'm saying?
Mhm.
So, well, let's try this then. Okay, so hold on. Me
Exactly right. Let's see if the spaghetti stinks.
whatever your analogy. Okay, but let's try it here. Okay, so then what we want to do, SW phase whatever it is, right?
Right.
Okay, so then we take this, this is our table. So it's interesting that, see, max, no, what we did isn't right. What we did isn't right. Do you understand? We don't want just the single element. We want, what do we want? We want the elements. Okay, do you get what's going on? Okay, this one here, what do we want from that? What do we want to get out from that?
The phase and the extra bits added at the end.
Which is just a single one in this case.
Mm-hmm.
This isn't what we want. That quotient remainder is not what we want. What we want is instead drop. Okay, so here's what I think we want. I think we want drop of hash, comma, quotient, length of hash, comma 3. Okay. Okay, so now this
Sounds
is what we
good.
get. No, but look what happened here. So this didn't
That's
work.
too long though.
Right. So this is in fact 3 times quotient. Okay, that's what we get there. Right?
Doesn't seem quite right. You've got 2 items returning 2 items, whereas Max has only had 1 returning 2 items. And the single case where the phase and the addition lined up.
Well, okay, so you tell me what's wrong here. Okay, so let's say TS pattern evolve list. Let's say, I don't know, hash comma 1 slash at tuples, let's say 1, 0, I don't know, 4. Oh, pattern evolve, I meant. Okay, so that's what that gives. Now, these tuples, okay, so 2SW phase form okay, those are the initial conditions according to me, right?
Mm-hmm.
And then TSSW phase step.
Actually, let's try. Let me think. Why? I don't understand why all of these have the same. Oh, that must be the starting phase. Okay.
It's the starting phase because they're of length 4. Right? So this one here, 1, 1, 1, why is that starting? Oh, I see. Wait a minute. In our phase form, only the 1 matters and another 1 matters. Okay, here. Okay, so this is otherwise known as okay, so this is supposed to be 1, 1, 1, 0, 1. Okay? So is this correct?
Mm-hmm.
Is this correct? So it's 2, 1, 0, 1. So it's 1 there, 0. Wait a minute. You know, this is a stupid representation, right? Because really what we're saying is it's a bunch of 3-isms, and then it's a remainder at the end. You see what I'm saying? You see what I'm saying? So it's a 2. So really, the better
Yes.
representation would be the sequence, the
That pattern of all looks wrong.
Okay, look, it should be the space sequence and the residue. Okay?
Right.
The space and the residue. Do you agree? So in other words, what that should look
Yes.
like is, so I mean, this is a kind of a okay, so really what we're wanting for here is a mod form. Okay? So to mod form of list is take list comma 3, comma, and then the residue, which is at the end, it's what gets left over. It's the remainder. Yeah, it's basically the remainder at the end, isn't it? It's just list. It's just take list, comma, mod, length of list, comma 3. Am I wrong? So in that
That's
case,
a different way of doing it.
well, but it's a clearer way of doing it. Right? Okay, so then we say to mod form of 1 1 0 0 1 1 1 0 1, for example.
And that should be minus because you're taking it from the end of the list. And that's probably why Max has it switch. I'm guessing he initially did it in that way.
Well, whatever. I mean, so this is okay. So here that's 1 0 1. Why doesn't it have the residue here? Wait a minute. This
Because there is none. It's length 9.
oh, it's length 9. Okay, so if I put length 10, there'll be a residue of okay, that's wrong. That last element is wrong there. Do you agree?
No,
it's not.
I
No,
think
no,
it's
that's not.
correct.
Okay, so that's 1. That's the next block. That's the next block. No, this isn't right.
Oh, okay. It refreshed. Yes.
Do you agree that it's the incomplete block? Right? The incomplete block. This shouldn't have an incomplete block here. So this is. Do you understand what I'm saying?
Uh-huh. The code would accept an incomplete block, though.
No. Look. We're repeating that. We don't want to repeat that. Do you see what I'm saying?
Mm-hmm.
So how do we not repeat that? What we want to do is the floor. We want to do the enough blocks. This thing here wants to go up to minus, how many is it minus? It's stride of 2 up to, I claim, something like minus 2. What do you think about that? Is that correct?
That sounds correct. We should probably calculate the mod for or the quotient first and then apply.
I don't understand. There's no quotient here. Look at this.
Okay, yes.
Okay, do we think that's correct? I don't think that's correct. That's wrong. It should be a null list. Oh, is that right? No, what should it be at the beginning? How do we represent
It's length
this?
10. It's
this
length
one
10,
here.
so that's correct.
This one here. That's not correct.
Yeah, it should be null at the start. Because it's an incomplete block.
Okay, let's try this one. Okay, so let's test what we get here as we say, table to mod form, table 0 blank, whatever, n 10. Okay, what's that case? That's the case of one element, right? Do we ever get to one element? What should it do in the case of one element? Do you understand what I'm asking?
Mm-hmm.
And do we care about that case? Okay, do we think these are correct? One element, two elements, three elements, that's the block, then it's null. Yeah, this looks right, except for this case of the single element here, right? What should it do in the case of the single element? It should be that null list followed by just the one element there.
A single element.
Right? Okay.
Mm-hmm.
And so why do we get this wrong here? So the second thing, okay, so that take, I wonder if we say up to here, is that going to be right? Absolutely not. Okay, so we're taking every third element. Okay, what should we be doing here? Look, you understand what we're trying to do. We're taking every third element. So what we want is take every third element here, which is elements 1. I don't understand why this doesn't work. If we said take that to element 2, why doesn't that work? Do you understand what I'm doing here?
Mm-hmm. I don't see why it's not working.
This seems like a bug in take. Do you agree?
Mm-hmm.
Are you paying attention? Yeah?
Yes. Cannot take positions 1 to 2 and 0.
Okay, how do we work around this bug? I mean, we can clearly work around it by just putting in a special case for that.
An if statement to see if it's got length, to see if it has length 1, and then put an if statement to return exactly that in that one case.
Yeah, but there may be a way of writing this 1 minus 3, 3. One thing we could do is drop up to 3 at the end. Okay, the single element case. Okay, that wants to go to, what does that go to? That goes to null list followed by the single element, right?
Right.
Okay, let's try this again. Now, what about the case of a null list followed by a null list? What should that do? I think that should be a null list followed by a null list, right? So that's to mod form.
That's a case to halt.
Yeah, I know. Okay, all right, fine. There it is. Okay, so now we've got those mods, right?
Mm-hmm.
Let me just add that in here. Phase representation, and then now we want body residue representation. Body plus residue representation. Okay, so now, so that is of the form spaced, you know, S1, S2, S3, and then residue, right? Okay, so now,
Correct.
what does the evolution look like in this case? Okay, so now what we want is so this is probably wrong. Okay, so TS Mod Step is of SI, comma residue, right? What is this equal to?
Right.
So this is, we're taking the beginning of S1, right? This is simply rest of S1, okay? Then it has to append something to the end of that, right? It's rest of S1, but it's looking up first of S1 to decide what to do, right?
Right.
Okay, so what it's doing is it's taking the residue. I wish I didn't have to figure all this out. This is really frustrating. Take the residue, and then, okay, so if there's a 0, so the original rule is 0 goes to 0, 0. 1 goes to 1, 1, 0, 1. Okay, so what we're doing now
Right.
is each of those we can think of in a mod form. So what we're doing is we're taking the residue, taking rest of SI, that's fine. Then we're adding this to the residue, and then we're reducing the result, right? So what we do is then we say join of the residue, comma, first of SI, and then we're saying, well, we could say 0, 0, 1, 1, 0, 1, 1 plus first of SI, okay?
Mm-hmm.
Right? And that's joining that residue. And then all we have to do is we're saying take the mod form of that. Am I making sense?
Yes.
And then that mod form, we're taking the it's join rest of SI with first of hash, comma, the residue, which is the last of hash. Do you agree? I claim that's the step.
Yes, that looks right.
Okay. Okay, so let's try TPS Mod Step. Okay, so here's what we're going to do. We're going to check whether, okay, so here's what we're going to do. We're going to say tuples, let's say 1, 0, comma 5. Okay, so here's what we're going to do. We're going to say this, each one of those TS pattern evolve, comma 1, and then we're going to say 2 mod form. Okay, oops, of hash.
Mm-hmm.
And then we're going to compare that with TPS Mod Step of T2 mod form of hash. Okay, now we'll do that with tuples of 1, 0, comma 5. Okay, and now we're going to say triple equals. And we're looking good there. Okay, now because we are persnickety, we're going to do the following. We're going to say table of this, n goes from 0 to 7, let's say. Okay, so we've got some problems down here. Okay, you seeing that?
Yes, with the first 3 steps.
Right, with the case where it's shorter than...
Tuple 0 won't work anyways.
Why not? We'll just give a null list.
Tuples of length 0.
Yeah, just go with the null list, it's fine.
Okay.
Right? Okay, so let's take a look for t less than 3. Are you still with me, or are you off someplace else?
No, I'm
okay.
watching. I basically want to see what it was doing for 2 mod for TS pattern evolve 0 to...
Okay, so here, the first form is perfectly happy, but the second form is failing. Okay? So I'm wondering whether the second form is failing simply because the 2 mod form doesn't work. That works. Okay.
The take may not be working right on the empty list.
Hold on. First has 0. Oh, no. It's a much simpler problem. Oh, wow. You see what the problem is? The problem is that it doesn't know. You see, if first fails, right? First could fail because there is no first element there. You see what I'm saying? There is no thing. So really what that is,
Right.
This needs to say, if first fails, then it's first of res, I claim.
Okay.
Then I'm saying?
Yeah.
Why the hell did that fail? Oh, because it's not that one that's relevant. Silly me. It's here. I'm confused. Why is that saying first of nothing there? One plus first of that. Okay. Okay, so let's look at the first element here. Okay, that was fine. Okay, so what's failing is the TS mod step. Let's just check that that's really failing. Oh, here, let's go down here. Weird. Okay, so let's look at this more carefully. Okay, why does it ever get to first of null string? Okay, hold on. Let's look at, okay, first thing is to look at what just the pure to mod form thing gives. Oh, we really need to have, let's just say, okay, so there are those things, right? Everyone has a null list at the beginning, right? Okay, so now let's say TS mod step of, let's take the most extreme case, null list, null list. Oh, shoot. Okay, that case I think is a special case. I think it can't do anything in that case. I don't think we can deal with that case because, do you understand what I'm saying? Because that has, it's the first of the residue. The residue, okay, so let's consider this case here. Okay, where's the rest here? Okay, if there's 0 elements, we just do this, I believe. Wait a minute, doesn't rest do that? Doesn't rest have an argument? Why doesn't rest have a... Why on earth does rest not support the same thing as first? Ouch.
For me, it would be handy if rest, first, and various others would return an empty brackets for empty brackets. That would save me a lot of debugging.
Well, it's the wrong thing to do.
True, but I'm
It's the wrong
constantly
thing to
working
do.
around it.
I know, but that's why you use the second argument to first. Right?
Mm-hmm.
Okay, is that correct? So that says a 1
We'll know when we
turns
try it
into...
out.
Okay, hold on. No, it's not correct. Well, the truth is, that hasn't helped us at all. That first doing that hasn't helped us at all. So the truth is that this is only for SI of length greater than 0.
Right. Actually, we could do a second TS mod step that has the empty
Yeah,
brackets as the
I
first element and special handling.
think so. I think so. Okay, so now what is the special handling? TS mod step of null list, comma, res blank. Okay, so what is the handling? What we're doing then is we're just saying there's no rest, there's no join, anything. And this is now first of res, right?
Mm-hmm.
In fact, the result, I believe, is just to mod form I believe it's that. Oh, come
I'm
on.
waiting for it to refresh. Yes, I think so.
But it did the wrong thing here. What the hell? To mod form of join? Why is it doing that? This pattern says if it's length more than 1, right? Actually, what we could do this is as simple as this. It's blank blank. List blank blank.
Okay.
Okay, why didn't that work? What the heck? Okay, so this is the second thing, blank blank TS mod step. Okay, so let's look at TS mod step in this case. I don't understand. Why did it do that? Why did it use that pattern?
I don't know.
Oh, there's a special case here. TS mod step of blank 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 simply goes to blank blank blank. It simply stays the same. That's a special case. right? So
Okay.
this is res colon blank blank like that. So that's clearly the case.
Okay.
Fine, that's that one. All right. Okay. Oh, piffle eyes. Oh my God. How could that be wrong there? Okay, so we did something wrong in this case here, where we have this thing, right? And we say TS mod step of that. Okay, so we claim it's this, but now if we look at, so that is simply 1. What does 1 map into? What does 1 turn into? 1 turns into 1,
1101.
okay, which should be what? Yeah, it's not, this isn't right.
1 in the first part.
And then a single 1 in the last part, so this isn't right. You see what I'm saying?
Mm-hmm.
So this isn't right here. Okay, so how do we get this wrong? This is, it's not join res. Right, this is wrong. It's 1101 at the end. I think it's join nothing to this. Right, I think it's just this. Okay, that's right, I think. Oh, for goodness sake. It's going to drive me crazy. Okay, so hold on. Let's look at this. Okay, so this is 1, 1. Do you agree that it goes to, okay, so that's 1, 0, and that should go to 0, 0, correct?
So
Right?
that's a case of just 1.
Just a single 0.
It'll be I think it returns to itself. Because it's you're starting with just 1 that goes to 1101 when expanded. You chop
Wait,
off the
wait,
first
wait,
3
wait.
items, and
The first 3 items would make it go to the null list. Right?
that's true.
Okay, so this is wrong here. So what is the correct version of this? So we're failing to chop anything here. So there's nothing to go with. What happens if we end up with 0, 0? What happens if the end result is 0, 0 and we chop 3? What does it do? Oh, I see. We chop 3 in that case. It should be, what should it end up with in that case? Do you understand my question?
With 001 to start, it's a trigger, since this is the condensed form, so that will basically add 00 to the end of res, and 0 is taken off.
Sorry, add 0, 0. So what do you think the answer should be in that case? So what should this say?
I'm thinking you just want to return a halting state or blanks or something, because a
But that's
mod
not
step
right.
of,
Look, the other thing returns something, right?
well, it has a length of less than 3, and you're chopping off 3 as the step. So basically, it's going to disappear. You base modding something with a length of less than. Actually, no.
No, that's not right. You just have that residue. It just stays as the residue, right? Look, what does... Okay, so let's look at this. We're just taking tuples of 1, 0, comma 2. Okay, there we go. And we're saying, what does TS pattern evolve that comma 1 give? Okay, so it gives these, right? So actually they all stay the same. Ah, I see. With the pattern evolution, they all stay the same. Am I making sense?
Yes.
Woof, 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 woof. Okay, so I claim that if it's less than length 3, which means that it has a null list at the beginning, right? So I claim that the following is correct, that it's incredibly simple, that this just goes to the unchanged thing. Do you see what I'm saying?
Yes.
Bingo. Okay, so that's what we're doing here. So okay. So then let me just summarize this. Okay, so the mod form is that. And then the evolution. So let's do a sample of the evolution. Okay, so here's a sample evolution. By the way, this is another thing. This is the continuous sequence evolution, which is another thing we should look at. Okay, so that's a representation of everything that got produced.
Right.
Do you understand what I'm saying? And we should look at that in this form as well. Okay, so here we can say TS to mod form of that. Okay, now we can say we've got an initial state that looks like this. Now we can say nest list TS mod step of that thing, comma 20, for example.
Right.
Okay, magnificent. Okay. Now what happens with a continuous sequence? With this form here, what does happen to the continuous sequence with that form there?
My screen is on about a 15-second delay, by the way.
Okay, well, I'm asking about this continuous form. Do you understand what I'm talking about there?
Yes, basically this isn't chopping anything. It's basically showing its growth.
No, it just doesn't. Yes, it's showing how things are added. But what is the continuous, what is the body plus residue, continuous body plus residue sequence? You see what I'm saying? That shows its full history, but doesn't have any extra pieces. Doesn't have anything that it doesn't care about. Or does it in fact end up caring about everything later on? Do you understand my question?
At a certain point, it won't. Yeah, at a certain point, it won't care.
No, but I understand. But so what's the representation of this where I combine together all these steps? Do you see what I'm saying?
Mm-hmm.
Oh gosh.
Okay.
You know what? I have to take this call. Can I call you back in about half an hour?
Sure.
Okay.
See ya.
Residue. These what should we call this representation?
Condensed form.
Blocks plus residue.
Condensed form.
Yeah, maybe. Okay. So is it obvious how to do this continuous version of that? So here, this is simply appending. Everything we append, we put in this sequence. I think that's the only other thing we can do here. I think at no time, what's the relationship between the flatten of this and the continuous sequence? Do you understand what I'm saying?
Right. With the continuous sequence, you basically lose the starting behavior, but the starting behavior doesn't matter. So,
Well, hold on. Let me just okay. So you're saying here that we could just include the elements, the blocks that are added, right? That's the only thing to include. So here, if I take this and I say this and I flatten this, what am I going to get? Do I get something that is basically the continuous sequence if I do that? That's really weird. Okay, so what was the initial state here? So the initial state here is 1, so that's 10011, for example, right? Is that right?
right.
Okay, so this is that's definitely not the same as this. So in what sense, let's see, why is this different? Oh, this is different because there are pieces of the added sequence that it doesn't include, right?
Right.
And which will be, in fact, always irrelevant.
Yes.
So what is the analog? So basically, it's whenever I'm a little bit confused by this. Whenever we add something here, where is the unique data? Is only the residue what we need, or do we need the initial as well?
You need both.
Okay, so what's the minimal thing we need if we're going to reconstruct the whole sequence? I mean, clearly you can reconstruct the sequence by just rerunning the computation. But I'm saying without rerunning the computation, what do we do? Do you get what I'm saying?
Well, if we given one of those, you just basically substitute in blanks.
Given one of which?
That one is basically 1 blank blank 1 blank blank 0 1. Any one of those.
No, I realize that. I realize that. I'm asking, this continuous sequence shows me the whole evolution of the system, right? Not just one step,
Mhm.
right? What's the analog of the
Right.
whole evolution here? You see what I'm saying? So it's like, what
Right.
things are being thrown out here? What things are being, so this is TS Mod Step.
Yeah. Do you really need that node? I don't see where that's really all that useful.
Well, I just think it might be an interesting thing to have.
Because
So,
basically the compression is for speeding things up in certain cases. So
I know, but I'm
you're
just,
basically sacrificing something.
right. But look here, join rest of that with first of that. See, I wonder whether that's the thing you need, whether that's the only thing you need to sort of represent the behavior. Is the last element in each one of these things. Do you see what I'm saying? Is
Hmm.
that if we want to represent, so it's like this, hash sub 1 minus 1. I wonder whether that's, see, I wonder whether that's a useful, because that's telling us, is that right? Is that what, or is it that we need the first element of that? Because that's the thing that is controlling what happens, so to speak. Am I making sense?
Yes, but that output doesn't look correct. One characteristic of the evolve sequence is you can look at the end and tell exactly what generated it.
Okay. Well, I don't know what, okay, so fine. So let's ignore this. So now what we've got is this condensed representation, compressed representation. Okay, so now let's talk about the cycles. Okay.
Hmm.
By the way, we could draw this picture, right, with the compressed representation.
Okay.
So let's just see what that looks like. So this is this thing here. Okay, so what's the initial state now? So what I'm saying is, to get that initial state from this, I say two mod form, right? Of this, right?
Yes.
Okay, so that's going to be a representation of this.
Yes.
So what I'm going to do here is I'm going to take first of each of those. Okay, so
Right.
I'm going to do this, and I'm going to say, okay, so 500 steps. And then I'm going to say array plot pad right. Okay. That's really weird. Is that obvious that they're just stripes? Do you see what I'm showing? Right?
I think it is. Yeah, I think it is obvious.
Well, so the only real information then is in the launching of these stripes. So, in other words, so what you're really saying is, you know, how do I display this in a reasonable way? If these are just stripes, then this is all the information. Am I making sense?
No, because there's two pieces of information. There's the residue and there's the first, basically the first set of bits.
First bit, you mean?
Right, right. And you can see that that you can see that this is what's going to happen because basically you're taking off the first bit and throwing it away, and basically there's something added at the end, and so it's obvious that it's just going to be stripes.
Okay, so to de-stripe the stripes, I would say map indexed of that. And I think I want to just say this, if I'm not mistaken. Okay. So that's after de-striping. Okay, so that
Okay. What is that again? Rotate. Okay.
so that's basically making this not. I don't quite understand why it has.
I like the pattern.
Yeah, but why does it look like that? Why does it look like that? Why isn't it trivial? I mean, why is when we de-stripe this? Do you see what I'm asking? Look, let's take this and let's say just 50 steps, for example. Okay, it looks like that. Now let's do this for 50 steps and try to understand what happened. So what this is doing is,
What is the 2 mod form look like? Let's just see that. 111110.
what are you saying? Look, what this is doing is,
All right.
this is rotating right. What the hell is this doing? Successive steps, it's rotating right by a certain amount. So that means that that pixel there why is it, why do we rotate right? Why aren't we rotating left?
I was wondering that.
Seems wrong. Yeah, it's more correct to rotate left, isn't it? In fact, this should be rotated left, I think. Oh, that looks more sensible, actually.
Is there some sort of middle padding we could do?
What do you mean by that?
You would put the residue after the padding.
I don't understand.
So it would have the first part, then padding, then the last part.
By the way, this is, do you agree that this rotate left is more correct than rotate right? Well, this is, no, actually, this is by 3 times first of hash. Yeah, because that means at every step, no, it's rotate right, isn't it? At every step, it's making a stripe off to the left, right? So at this step, what I want to do to correct those stripes, right, to make the stripes go straight down, what I want to do here is I want that one to be rotated right, don't I?
I think so, but you'd want to do it after the padding.
Well, no, but I'm talking about before. This is the case before we yeah, okay. So that's that case. That's fine. That's rotate. It might be the case that we want to do, well, it doesn't really matter whether it's -1. It's probably more correct to do -1, I think. Won't make much difference. Okay, what do you mean by after the padding?
That way the core part of the rule wouldn't be modified, but you'd
Okay, so just tell me what to do. So you
use
understand
vertical
what?
stripes instead of.
Okay. You understand what we're doing here. Here we're taking the first of the thing that is the compressed blocks. Now, what are you saying we should do?
That should be padded.
Okay, but what do you mean by that? Just tell me what to do. I've got the residue. What do I do with the residue? Do you understand what I'm saying? I've got this.
You can throw the residue away.
That's what I
So
did.
basically the map index would come out,
That's what
and
I did. There
the
is no
map index
residue.
would come outside of the.
That's exactly what I'm doing. Look, I'm
Mhm,
taking the first element without the residue, right? That's exactly what I'm doing.
mhm,
Now, what else should I be doing?
right.
There's no padding here.
Pad right. No, there is. You've got pad right.
Yeah, that's why I've got gray here.
Right. I'm suggesting you do the pad right before the map indexed.
I can try that, but I don't understand why that would do anything even vaguely sensible. Okay. All right.
Because the blocks of data would not be altered.
You mean you get this?
Yes. Right.
Well, that's sort of interesting because it does show the generations here, doesn't it?
Right.
Each one of these is a generation. Now, what happens if I do it here? If I did pad right? That is interesting. Okay. You know, I'm pretty sure I did this in the NKS book of getting generations.
Mm-hmm.
So how do I extract the generations here?
You would basically pick out basically find where the padding was and take what was take the wrapping.
No. I mean, just directly from the function. How would I know when the thing has wrapped around?
Oh, by where the gray is.
No, I don't have any gray. I'm saying I take the original data here, right? And I want to know, I mean, I'm sure I did this in the NKS book, so I can go look at what we did there. Okay, so this thing here, how do I tell when it's wrapped around? How do I tell when there's been a whole generation?
Oh, I see. You'd basically count the initial number of steps and partition by that.
Say that again?
This has what 10, 12, let's see, 3.
No,
This has
I
12
don't
steps. So
understand.
basically
Each after this.
the first generation is 12.
No. Look at this. Okay. So this has to eat through the whole thing, right?
Right, which will take 12 steps.
It won't take 12 steps. It takes 1, 2, 3.
Oh, this
4
isn't the
steps,
compressed form. Okay. So 4 steps.
right? So, okay. So then what you're saying is, okay, so then what I do is I go through the 4 steps here. 1, 2, 3, 4 steps, and then this is all fresh data. Right? So that's the next
Right.
generation. So then I look at how many this is, but what if it isn't an even number of threes?
It doesn't matter. You basically will drop the remainder, and when you're that's where kind of the phase comes in. But basically, the next generation is, what is it? That is at 13 now. The next generation is 5 steps.
Okay, so tell me how to break this into generations. So, right, how do I generate?
You would basically have a evolve generation.
Okay,
It would be based on TS direct evolve list. It would count how long it was and
okay, all right. So let's
do
write.
that many
Okay,
steps.
okay. So let's say generational. Actually, I want it up there. Okay, so then what do I do? So I've got the step here, and what you're telling me is I should do. What should I be doing here? I should be
It'll be based on TS direct evolve list.
I don't have one of those, but I mean, okay, fine. I can do that with TS
It's
step.
a second from the bottom.
Okay. All right.
That one there.
Why
And
does it have that length?
basically you'd
Why does it have the length greater than whatever?
oh, I don't know.
Okay, whatever. Okay, all right. Then what are you saying? Yeah. TS generation
So basically
evolve list init T. Tell me what to do.
I use G instead.
No, I don't want to do that. It's all right. It'll autocomplete. Don't worry.
And then well, I usually will do a module, get the length of the init, mod 3.
Look, what I
I
want to say
guess
is
you just need
nest
the
list
quotient.
of. I don't want TS direct evolve list. I want TS direct evolve. I just want to evolve it for that number of steps, right? Right. So the init of the given hash thing, whatever, and then this is going to be starting off with init, and it's not going for T steps.
Right.
Right. It's going for. Well, I could do outer T. That's a different T there. That's T generations. TG, the number of generations, right?
Right. Mm-hmm.
Okay, so here you're saying I want to say quotient length of hash, right? Quotient of that, comma 3. Is that correct?
Yes. Uh-huh.
Okay. So then you're saying I can say TS generation evolve list
And you could do, say, 4 generations, so 10, yeah.
Okay, so now I say array plot of pad right automatic 0.5. Okay, and now I go, let's say 30 generations. Oh, that's cool. 50 generations. That's nice. That's nice.
Mm-hmm. I'm not sure what that one is doing, but it looks really cool.
Well, let's get a bigger one because we've got much bigger ones. Let's get a much bigger one. Let's see. Okay, where do I have my bigger ones? Where do I have my bigger beavers? Champions. Well, let's do the one that, I mean, this one is like, okay, so that's that one there. And that would be, I mean, we're not going to be able to do it for that many steps, but let's just do this for like 500 steps. No, 100 steps. Is this going to get really big? Okay, how do we use Max's code to do this generational evolution stuff?
Should work the same way. It's just a matter of counting the size of the init.
Actually, look, in here, we shouldn't be using TS direct evolve. We should be using TSQ evolve. Because
Okay.
it's distinctly faster. Actually, we could just use oh, for God's freaking sake, this is so stupid. Well, that's kind of interesting.
Uh-huh.
There's my summary notes here. Okay, now, what is the generational analog? What is the analog of generations for the compressed evolution? See what I'm saying?
Mm-hmm.
So I think all we do there is we just do the same computation, but instead of quotienting by 3,
it's just the length.
just what?
It's just the length of the first part.
Right. So okay, so here the init well, let's just use the same initialization, I guess. Let's just do that. Init is just a list of integers. Then this is to_mod form of that list of integers. And then it's this comma length, right?
Yes. Length of the first part.
Oh, yeah.
Or the init.
Not the init, it's the first part.
Okay.
Okay. So then this TS generation mod evolve list. Or we can do the same thing here. And here we just want the first parts of these.
Uh-huh.
Okay, what the hell is that? What? Okay, first we convert this to mod form, right?
Yes. I was about to suggest that.
Well, no, but I did that in here, to mod form of that. Okay, so now, for some reason, TSQ evolve does, I'm sorry. This is, we need to use Max's code. What is Max's? Oh God, and we have to unpack Max's function. So this is instead, we need to unpack, we need to convert from Max's function. Okay.
That looks more correct.
Well, that's dandy. I mean, it looks very similar to the non-generational one.
Uh-huh.
I mean, not non-compressed one.
Right.
That's definitely cool. I mean,
Mm-hmm.
let's look at this one.
I think it looks better than the. Actually, that's not a good busy beaver because the 3 zeros at the start don't add anything.
Not 3 zeros at the start. Where?
You're the next line down.
Well, that's our 20 million busy beaver. We may
Right,
have
but
found it
it'll
at
be the
random.
same without those. Right, it'll be the same if you take off those 3 zeros at the start.
Okay. Well, I mean, yeah, okay, fair enough. Well, okay, so let me understand. So, okay, so these are, this is sort of a signature. Okay, so this particular picture, we should be able to make with Max's code, right?
Right. Mm-hmm.
Let's understand how to unpack Max's code. Okay, where do I have Max's code used? Okay, so his code is post tag system. Okay, so let's call it max mod evolve, right? That's what we're basically going to do.
Okay.
Okay, so it takes take and return SW compressed representations.
Mm-hmm.
Okay, so now what does Max's code do? So Max's code takes, where do we have an example of Max's code? I think I have it in, Okay, these were big busy beavers. Oh, that's just a thing called post-tag system final state. Okay. Must be a multiple of 8. Okay. All right. So what are we doing here? So how do we convert it to this form? Okay. Okay, so we say max SW to max of the mod form, which for me is SI blank and then a residue, right? Okay, what is the max form of that? Okay, so the SIs are the same, correct? Or are they not the same? Is that not the same? Is that the same? No, it's not the same. Well, but that, no, it can't be the same.
No, it's the same. It's
not. Where's the residue? The residue is the end element of this.
No, there is no residue. He just has a mod.
No. For 0, there's no residue. But if that wasn't 0, how would I read off? Okay, from mine, how do I get Max's form from mine? What is it equal to?
In that post-tag system final state, is that the compressed form that's being fed in?
Yes.
Or not?
Yes. It's the compressed form that's being fed in. It's the compressed form that's coming out. Okay.
Okay.
Okay, so there's a typical example of a compressed output. Okay, so what exactly?
I think your S.
Okay, here it is. Max.
What you have is SI is the second part.
Bullshit.
That state
bullshit.
corresponds to your SI.
Bullshit. That's not right. Because there's more information. You need more than just the phase. The phase, it's got to tell you, in my case, where does this residue come from? See what I'm saying? Do you understand what I'm saying? It can't possibly have the same information unless you take that. Look. There's that. You see what I'm saying? That's the thing that computes with his thing, right? It does this wacky thing where you see what it's doing? You see what it's doing? It's got this residue piece, right? Okay, so can you figure out what do you understand? I've got to turn it from this with a residue, right, to this form, and then back again, right?
Right.
Okay, so it's the phase and the state in his case, right? So what is it to get it back to my form? I'm getting myself a little piece of something to eat. Why don't you think about that for a second, right? You understand?
Okay.
Okay, I'll be right back. Hi. Okay, did you brilliantly figure this out? Did you figure this out?
Well, his system and your system both have the important part, and I still think that your SI corresponds to his state.
But it's got to be information.
And we can test that out.
Okay, well, what should P be?
We can test that out.
Okay.
I believe P is the length of your residue.
Is it, or is it, does it have, is it 2 minus the length of the residue?
It'll be something. We can just do a little bit of experiment and one of them will work. And there's 3 experiments.
All right.
Now his post tag system final state, is that a generational thing or is that just running the number of steps given?
I think it's just running the number of steps given.
So let's do that for 8 steps and let's just see whether the first 8 digits are dropped.
Looks like it. I mean, yeah.
And now run yours with a 0 residue for 8 steps.
Okay.
With a empty bracket residue.
Okay, hold on. Hold on. What is my function? I want okay, so let's say TS mod evolve of SI colon blank blank. No, I don't want that. SI blank colon res blank comma T is nest TS mod step of that comma T.
Right.
Okay, so now I say TS mod evolve of this thing, comma, brace for 8 steps. Well, there does seem to be some similarity there. All right. So you think that?
So let's add a couple digits to both of these, like add into one. We basically want to knock this off phase.
No, hold on.
And then
The max to SW is going to be, he has a phase. So how do I get my form from his?
let's try and experiment. Take out some of the 0s and 1s on each of these, like take off the final 0 or something, and that will knock it off phase, I believe.
Okay, there we go. Okay, makes sense.
And then put this right. Mm-hmm.
Now here,
And there, okay, yeah, okay.
So his 2. So I should fill this in. Okay, max to SW. If max puts a 0 there, right?
Mm-hmm.
Correct. If max has phase 0, then that corresponds in my case to
Empty brackets.
Yeah. Okay, hold on. State, comma, like that. Okay. Max to SW. 2, comma, state. Is my state, comma, list 1. Do you agree?
You could use 0 or 1. Doesn't really matter.
How can it not matter? That residual
Because
event.
that residue is going to be lost.
Why? Why doesn't it come back to be used?
Because it's in a position where it'll be chopped away without ever being read.
How can you tell that? Doesn't it depend on how?
We can run.
Okay, let's say 1 comma state. What should that be? Do I do the experiment?
Double ones. State, comma 1 1.
Okay. So you claim that the only thing that matters is how long the residue is.
Yes.
Well, then why am I bothering? I guess because it's a faithful. Why am I bothering to record
Yeah, there's.
what the residue is? Or it never matters.
That's right. That's why Max didn't bother to record it. That's why he just went with the phase.
Okay. So maybe I don't want to record it. So, but in my functions here.
And your SW to max.
Okay, but my functions use the residue here.
Right, but basically it's just padding.
So it doesn't matter what the residue is. So what does Max put in there?
He's probably using some sort of indexing to keep track of where the chopper is at all points.
No. But what does he put in? Because it's going to give a different answer, right?
He's basically skipping over. If you look at his TS max phase step, he's basically ignoring anything that doesn't matter.
All right, well, so what are you saying Max to SW should do here?
SW to max, instead of length phase, it's 3 minus length res mod 3.
The length of the res can never be any more than 3. Is it 3 minus or isn't it 2 minus?
Yeah, yeah, 3. Yeah, it's no, I think it's 3 minus, and then mod 3 around that, and that way 0 goes to 0, 2 goes to 1, 1 goes to 2.
Like that. Is that right? I can't.
Oh, I'm on a 15-second delay.
That can't possibly be right. How can that possibly be right? It's a big negative number. Is that right?
But not mod 3, it's not negative.
Oh, fair enough. You sure it's right?
Yeah.
Okay, but I think that my representation. I mean,
the length is always 0, 1, or 2.
Okay, fine. Okay. But my representation is kind of stupid because I mean, I'm appending this residue, but as you say, the residue doesn't matter. It could just be 0, 0, correct?
Right.
Maybe I should make these zeros instead of ones.
It won't matter.
Well,
They
I
could be
understand.
blanks.
Okay, so you're saying that in here, that what I should do is, okay.
Well,
Let's
I,
write
I
this.
think this is fine because you don't have to explain as much. I mean, the phase thing is all fine and good, but it's tricky to explain. Here, you're just leaving the residue in, and you don't have to explain it then. So this is simpler code and simpler to explain.
Well, all right, okay. All right, fine. Okay. So, all right. So let's max mod evolve. Okay.
Mm-hmm. For a generation.
No, I was going to do it just for not for a generation first.
Okay.
Okay. Actually, for a generation, it's not trivial because of that 8.
Right.
Okay. All right, so wait a minute. So at least mod evolve max should take an SW form thing. That's SI blank list, comma, res blank list, right? And what should it do now? So it should go, oops, and then a T. So it should go SW to max of SI and res. And then it should be post tag system final state. Right, is that right?
Mm-hmm.
Comma T. And then it should go max to SW of this. Okay, so let's try this now. Okay, mod evolve max of, let's say this here, comma 16, let's say. Okay, now I want to try TS mod evolve. Actually, this should be called TS. Okay, now it's TS mod evolve of this. Okay, why is that different? Why is that different? Something went wrong.
the last zero got removed for some reason.
Well, I mean, there's arbitrariness, as you say. There's arbitrariness to how this gets done, isn't there? Or is there not?
No,
I mean,
there isn't.
Okay, so what happened here?
The last digits are different. Everything else is the same.
No, but okay, I'll be right back. Okay. Did you figure it out?
Try running that. Yeah, try running that first example with 8 steps for both.
Which first example?
The one at the top there.
This one here.
No, not that one. The one that has the 0 phase. That returns a 0.
This one here.
Right.
Okay. Okay. TS mod evolve, and then 0 phase means I put a null thingy at the end, right?
Right.
Okay, so that was correct. Right? You think that thing run 16 steps will be correct? I'm trying it for 32 steps for a time until it gets a different phase. Okay, there we go. It gets a different phase there. Okay. Okay, it's wrong there. Okay, so something is wrong. Maybe it's the SW to max is doing the wrong thing here. Do you understand what I'm saying?
Oh, something is happening wrong with how it's returning the last result, because the only
That's this. That's max
difference.
SW.
I think you are correct. I have a suspicion Max's code might be wrong, and the last digit.
Okay. Can you write that up and tell Max?
Sure. Might be easier just for you to copy what you've got there and ask if the final digit in his examples is correct?
Well, look, I don't understand. How could this even possibly be right? Look, TS mod evolve max returns something with a 1 there. But my code, oh shit. I didn't do this. Look.
Oh, okay.
Okay, so it's returning that. My code here is returning this. Do you think it's always off by 1?
Right. Everything else is identical. So it went 56 steps and returned the same thing, except for the final digit.
Okay. But that final digit really matters when I'm feeding it into the next phase of evolution. So if that's wrong, we've got total garbage.
Correct.
Well,
However, yeah, I don't know.
well, I don't think he got it wrong. I don't think he got it wrong. So I think we got something wrong in the conversion.
Okay.
Okay, so let's look at this more carefully, right? Are you sure that we're supposed to take the whole state here? Do you understand what I'm saying?
Yeah, that's a good question.
Isn't the residue? See, I don't believe in this thing that the residue does not depend on the state. I just don't believe it. I think it's wrong. I think what's happening is that we should be taking, in this case, we should be taking, I'm claiming that this is take state comma minus 1. And that this is take state comma minus 2. That's what I think.
Oh, that sounds interesting. Certainly worth trying.
Okay, so this is TS mod evolve. Oh, and this one here should say drop state comma minus 1. Drop state. This is actually take drop or drop minus 2, I claim.
Okay.
All right, let's try running it in a more serious way. Okay, so we've started off with this. Okay, so let's go ahead and nest this. Oh, for goodness freaking sake. Why didn't that work? Oh, nest list is what I want. Okay, so now I'm going to do the same thing, TS mod evolve max. That's not a good sign. They don't look like they're the same. 101. Well, let's just find out. Oh, My 10 might be different here. Okay, so hold on. Oh, for God's frigging sake, this is completely different.
Mm-hmm.
Do you see it?
Yeah.
Okay, so in this case, 0. Okay, that one is different. That one there to this one here. So that one there, if I say TS mod evolve, that thing there, comma 8, I get that. TS mod evolve max, I get that.
Right.
I think that has to do with chopping. It's to do with the way this is working, right? Do you understand what I'm saying?
Not sure where you're pointing.
Well, I'm pointing over here. I'm
Yes.
pointing at the way that
Right.
this is dropping. Okay, so the claim is that the raw code is going post tag system final state. Okay.
Mm-hmm.
And then that is 0, comma that, right?
Mm-hmm.
And that's 8 steps. Okay, so that is now phase 1. Okay, do you understand what I'm saying here?
Right. Mm-hmm.
Okay, so then this, let's find out the length of that. $19. Okay, so let's then take the length of this, take this, comma 19. Okay, drop that, comma 19. Okay, I don't understand what's happening here. So TS evolve max. Okay, so this is the final state, right? So we said this is phase 1. So in phase 1, we said take the last 2 elements here, 1, 0. We said take the last 2 elements in this case, right? Do you understand what I'm saying?
Uh-huh.
That phase 1 means take the last 2 elements and make them the residue. Do we think that's correct or not?
I don't think so.
Well, then explain what's going on. Because what I'm saying here is the residue is 0, 1. Right, so this has an extra 1 at the end. Do you see what I'm saying?
Mm-hmm. I think we may have been closer before.
Right. Look, I'm telling you, you can't make up data. There's no data to make up. Right? There's no arbitrariness here. You can't just fill in an arbitrary
Okay.
0, 0. Okay. So, okay. So what do you think it should be? So do you think this is correct? Do you understand the question? Because
Uh-huh.
if this is correct, then I don't see how the other one could possibly be correct. Right? Because it's got to go two ways, right?
Right.
So this quantity, all we're doing is we're solving for this quantity, right?
Right.
Makes sense? Okay, so let's solve for that quantity. So what does that mean?
Uh-huh.
So actually, the claim would be that max to SW, which is claiming to have arbitrariness, which I do not believe. I simply don't believe this. Okay, so this you then claim is state, comma, and then how many elements are there? Do you understand my question?
Uh-huh.
But we already know this is wrong because this is saying that
Well, before we could run it for 56 steps and get the identical behavior except for the last digit. So basically, we just need to figure out how to fix things so that the last digit, there isn't a conflict there. And then everything is perfect. They both match up.
I know. So tell me how to do it.
I think we should go back to what the code was and then start taking a look from there.
Okay, so you think these are wrong. You think it's the full state, right? So this is mapping the length of the residue. So
Well, I
this,
don't think you should delete those ones you just deleted. I think you should put those back. Because we're going to be needing to do a little bit of playing around.
okay, all right, go ahead.
So,
Okay. So this here, this function here, I want to make this a little bit clearer.
okay,
So the length of that residue table 0. I'm sorry, m comma that, and m goes from 0 to 2, right?
right,
Okay, so I'm just going to make this be just length of res zero to one plus length of res.
okay,
Okay, so the inverse of that is simply, tell me the inverse. 0 maps to 0, 2 maps to 1 maps to 2, right?
right.
Okay, so it's simply this right? That's the inverse, right?
SW, no, because your SW code has a list of length 0, a list of length 1, or list of length 2.
Mm-hmm. P can be 0, 1, or 2.
Oh, I see. Okay. Okay, right, right, okay. Yes.
Okay.
So let's try those with TS Mod Evolve Max and the TS Mod Evolve for 56 steps.
It's wrong.
Right. But they only differ in the last digit.
Yeah. But the length of the state information is different, right?
Right. There's something wrong going on there. And
Huh. Okay, I wanted to switch to a different topic here. Maybe I can send this to you and you can resolve this, okay? Can you look at this and try and resolve this?
well, I suspect that the problem is in Max's code. I've got a copy of Max's code. I can start trying to look through it.
I'm going to send you this.
Sure. Yeah, go ahead and send it to me.
Okay, but let's now look at something else, okay? I want to understand the cycle structure, okay?
Okay.
Okay, so now, how did your cycles thing supposedly work?
I found all cycles up to 46 bits.
Okay, I want to know how. I want to know what this generator actually does. Do you understand what I'm saying?
Oh, this isn't a generator. This is just data.
Okay, how do you find the cycles?
Brute force.
Okay, but explain.
That's how I found them.
So what you're telling me is, if I say I have all this code, right? So are you using compiled things, or are you just using direct
brute force?
Okay, TS step, right? What are you doing? You're saying TS step. What are you doing? Just go through what you're doing. Okay, I've got tuples, right? I've got tuples of length. Let's say I've got tuples of length 4. Okay. Okay. How do I find which of these?
Treat those as compressed.
Why are they compressed?
Treat those as compressed
Why are they
data.
compressed?
Because we're wanting to convert these. We want to consider this as something that's been expanded. You could just run the code. That would also work.
Okay, explain how I do it very directly.
If it's a tuple of length 5, you should return the original 5 element item.
When?
So basically you want to, what's that?
When? How? I've got to run it for n steps, right?
Right, run each of these for 5 steps.
Okay.
And pick out the ones that are equal to themselves.
Why is 5 steps the right number?
Because these compressed forms have
they're not compressed.
Of...
They're not compressed. Do you understand? These are not compressed.
Okay.
So, do you want compressed forms, or you don't want compressed forms?
Yes, I do want compressed forms. Compressed with 0 phase.
Okay, so that's otherwise known as TS Mod Step, right? TS Mod Evolve, right? TS Mod Evolve, correct?
Yes.
Yes, is that correct?
Yes.
0 phase.
Right.
Okay, 5 steps. /@ these tuples. Okay, so now you want to say, I want to get them back with 0 phase. Is that correct?
No. We're just looking at the first part.
Okay, so it was with any phase.
Right.
So select from tuples 1, 0, comma 5, let's say. Hash triple equals. first okay, so those are claimed to be ones that are compressed versions that will be repetitive. Is that correct?
Yes.
Okay, so I want the uncompressed.
They may not be.
No.
We actually don't know whether.
Wait, what are you
Go ahead.
saying? What are you saying? Are these cyclic or not? And why
These
are
will
they all
generate
cycles?
themselves initially.
Okay,
What's that?
Okay, what about after that? How do I find all the cycles? The cycles, all of the cycles, nothing
This
but the cycles.
right. You basically do this for tuples of each length.
Okay, so where's
before
the
you
cycle?
actually
Show me the cycle. What is the cycle? So I want to do this with an initial condition. I want to do this so that these are, let's see, where's my initial,
if
I say from phase form, right?
the ones of these with phase form 0 are the ones that will have cycles.
Okay, then just tell me how to make the actual original version. Okay, so from mod form here of s comma res, what is the what should I do here to make an original from mod form? And I put in a padding here, pad, where is my, okay, so from max phase form. So this is, okay, so tell me what I do here. I say, do you understand what I'm asking? Do you understand what I'm asking? Do you
I'm
understand?
not sure.
Okay, then listen.
No, I
We're
don't.
trying. Okay, okay, okay. How do we get from the compressed form in my version to, I think we just do a join of this comma res. Do you understand what I'm saying? Okay, so here,
Yes.
okay, so I say from mod form blank comma 1342. What the hell? Oh. Okay. All right. So your claim is that if I say TS pattern evolve list of this, comma, what? Let's say 20 or something, okay? Oh, for God's sake.
No,
No, it's not a
steps.
frigging cycle. What? It's not a cycle. Look at it. It's not a cycle. Do you see? It's not a cycle.
I'm not saying that these are cycles. These basically, but the next step does generate itself. And that's the first part of a multi-part problem, is finding the sequences which will generate themselves after one iteration.
Okay.
And I'll explain why that's extremely important a little bit later. But first you have to accept that these will generate themselves.
Okay.
If
fine.
you don't accept that, then
No.
you're not
There we
going to
go.
understand
There we
anything.
go. Okay, but this doesn't generate itself. Okay. No, it doesn't generate itself. It doesn't. Doesn't generate itself. It's not with, you see, because it's got blanks here, right? So it doesn't generate itself. See what I'm saying? The compressed version has more information than the uncompressed version.
All right. For 11001, do the substitution. 1 goes to 1101 and 0 goes to 00.
This one here. What? 111.
Yeah.
What should I substitute? 1 goes
0
to.
goes to 00. The standard thing.
Okay.
Right. Oh, right. Well, if you look at every third element, you'll see that it is the same thing. 11001. The the phase isn't 0 for this one though. So if you do the length, you'll see it's not a multiple of 3.
Okay.
Which is why it got thrown off.
Okay. So what should I do here?
You don't have to do anything. These are the tuples which will generate themselves in a first step.
These ones here.
Yes.
Okay.
And if you change it to 6, you'll see that it's 3 again, I believe. Oh, 5, right. And if you do 7, it'll also be 5.
Fever fantasy.
Yep.
Okay. Why do we think that isn't just the total number of things that don't have pairs of ones together?
Ask that again.
Okay. The number of sequences of a given length that don't have a pair of ones together is exactly the Fibonacci numbers. Right? If I just say select.
Okay.
Right? So here, for example, well, that's interesting. That has a pair of ones together, but the number of sequences. Did you understand what I'm saying? If I say in tuples 1 0, and I say of 6, for example, and I say that with partition hash 2, 1 free Q. Actually, I might be able to do x blank here. No. There's just a finite state machine with, yeah, see there. Okay, so if I do this of M, table that M comma 10, for example. Oops. Fancy that. See what I'm saying? Right?
I'm on a 15-second delay.
Okay. The number of sequences with no pair of ones adjacent is the Fibonacci number. Fibonacci numbers. Okay, you
Uh-huh.
understand?
Mm-hmm.
So I bet that's what's going on here.
Well, something like that, but it's more complicated because the other one is growing only half as fast.
Which other one?
It's 1, 2, 2,
I,
3,
I,
3, 5,
I
5.
see that. I understand that.
Mhm.
I understand that. So what we want to do here is look at. Okay, so here, what I would recommend doing is for this, I would say we want to count the number of things which are partitions. So what I want to do is I want to say counts of partition #21 that. Wait a minute. I don't understand this. So this is select from the tuples, right? Right? Am I making sense here?
Mm-hmm. Yeah.
Select from these tuples, and then I partition. Why the hell am I getting double? Did you understand the issue here? No. You see what I'm saying? For each of these, actually, what I really want to do is that. Okay, so this shows us the number of each of these tuples, right? Each of these paired tuples. Did you understand
Right.
what this is doing? Right. So for each of these,
Uh-huh.
then,
Uh-huh.
so these are not very remarkable. So these are sort of all over the place. Let's just see what happens if we did this. Again, these are sort of all over the place. Making sense?
Right. Mm-hmm.
It's not some regularity like that. But so what we have to do is understand if we were making a finite state machine, what would it look like here? Do you see what I'm saying?
Mm-hmm.
Right. That's going to tell us what possible sequences there are. Now, what I thought
Right.
you were doing before was something where you're looking at these. Okay, I don't even understand why this generates cycles. Why does this generate cycles? Explain.
When they have phase 0, it's a cycle.
But which ones have phase 0?
If basically if you expanded it and it had
Oh,
length divided by 3, it would be phase 0.
okay, so
Or
look,
basically if you just multiply
no,
the count of,
there's no custom multiplying the count. What we want to do is we want to say that this equals this and that phase is 0, correct? Am I making sense?
yes. Mm-hmm. Mm-hmm. Those will be the cycles, yes.
Okay, like this, right?
Yes. Except that's need something there somewhere.
Okay, hold on. Okay, so those are the phase zero cycles, right? Am I making sense?
Yes, but
Those are the phase zero cycles. So this is telling us that the number of distinct cycles is that.
right.
Okay. So here we've got the actual genuine cycles. 1100, 0101, etc., right?
Right.
Okay, so now I want to prove that that's actually a cycle. Okay.
Mm-hmm.
So what I'm going to say is I'm going to say from mod form of this, comma blank, is this. No, what am I doing here? Oh, from mod form of that, comma this, right, is that. Okay? So now
Right.
you're
Mm-hmm.
claiming that that is a cycle.
Yes.
Okay, let's go prove it. Let's take this. How long do you think the cycle is? Let's go 30 steps. No, I don't believe you. Look at it. It's different lengths, right? Well, it enters a cycle, but it didn't start as a cycle here. I don't understand this. Everything enters a cycle, so this is just crap. It's just crap. This isn't a cycle.
Oh, wait a second. Your pattern, it should be dash dash at the end. You've got from mod form.
Really? When there's a blank here?
Yeah,
At phase zero?
right. You basically need something has phase zero basically means it has a length divisible by 3.
Okay. This has a length. Well, okay. Why did it add a 0 at the end there? Well, that's then
Well, that's
wrong.
part of
That's a
the.
mistake in from mod form. Okay. It's a mistake there. So it should be, what should it be doing here? Do you understand what I'm asking?
Yeah, it
That's what
should
I
be
was asking
returning.
before.
Mhm.
So what should this be doing? It's riffling those things. And then is it doing that same jazz with this? No, it's not. No, it's not. Those are wrong. You understand what I'm saying? Those are wrong. If it's supposed to be a multiple of 3 when there's a no residue, do you understand what I'm saying?
Mm-hmm.
Then we got it wrong.
Right.
Okay, so let's get it right. Okay, so, okay, what do we do if res is blank? Do you understand my question?
Yes. Uh-huh.
Okay, I thought you'd work this stuff out. That's why I'm kind of frustrated. Okay, let's work it out again. Okay, okay.
I don't see why that's not working.
Okay, well, look. Let's look at this. Let's say 2 mod form of this. Okay, it's got a null thing at the end.
Oh, the riffle isn't is putting things between the items of S, but it's not putting anything at the end of S.
Okay, all right, let's figure that out.
It should be perhaps a table of.
No, wait. Riffle, which every nth element is X. Do you understand the story here?
Mm-hmm. I would change this
No.
to.
I want to know how to do this with riffle. 1 minus 1, 2, I believe. Except it isn't 2, it's 1 minus 1, 3. What is the correct form for the riffle? Is that right?
I hope so.
Okay, that looks right. Now this is probably wrong here. Do you agree?
No, because that's putting dashes before the one as well.
I don't understand. This one here from SW phase form?
No, the one you just ran from mod form, it's putting dashes on before the the sequence and after the sequence. That looks correct.
Okay. All right, let's try this then. From mod form here. Much better.
And
Okay. All
you could
right, I
probably do
believe you.
find transient repeat on that.
No, I can see it's right. Right. Okay, so this is the criterion then. This here, these are the cycles, right? Up to a
Right.
given size.
Mm-hmm. And you can change that M8 to M82 because all these cycles will have even length.
I know. Okay, so which ones of these, when I have blanks here, this will go to a definite form. So, do you understand what I'm saying?
Mm-hmm.
Okay, but there'll be a particular pattern of zeros and ones. Those blanks will be filled in a definite way, right?
Right. And after 4 steps, you get what you would do if you did the substitution.
What substitution?
0 goes to 0, 0, 1 goes to 1, 1, 0, 1.
Substitution on what?
On the original 1, 1, 0, 0. And did a flatten.
But is that a general feature of, okay, so this is also, okay, alternate, are you sure that's right? Can you prove that that's right?
Yeah.
Alternative
Uh-huh.
way to get the final cycle.
No, not that it's not a cycle. To get what would happen after if you fed in these 4 numbers into the post substitution, this is what you would get once you fed in all those digits.
No,
This
I
is
know,
what
but
would be,
I know, but that's then an element of the cycle. Yes or no? Do you understand what
depends
I'm
on the
saying?
phase.
No, it
Yes,
doesn't. No, it doesn't. It does not depend on the phase. It's an element of the cycle, right? Yes or no? This should be an element of the cycle.
it is, yes.
Okay, is it always an element of the cycle?
Yes.
Okay. Do you understand why?
Yes, because it has phase 0, and it's basically,
I see.
if you ran 4 steps, this would be at what would be at the end of the tape. And since
Right.
you've chopped off 4 elements, the original tape is gone.
Yeah, I get it. I get it. I get it. I get it. So this is length slash at that. Numbers of cycles. Okay. There are cycles with all lengths of the form 2k. And
Yes.
there are Fibonacci of k of them. Is that correct?
I'm not sure, because we're only selecting the ones with phase 0. I would run this for longer.
I don't understand. Run what for longer? I thought the phase 0 ones were the only. What are you talking about?
This
Run what for longer?
extend this table for longer. Do like M16, 2.
I don't understand. I don't understand. I don't understand. It's always phase 0. We put it in there, right?
Right. Mm-hmm.
So Fibonacci of 1. I mean, this is, so let's just make a table. Oh, it's Fibonacci of k plus 1.
There seems to be yeah, that seems to be correct.
Yeah, I think so. Okay, so now let's understand if these are all, okay, so have we observed any other cycles? 2, 2, 4, 6, 8, 10, you know, we get some of these cycles like 28 fairly early. For example, have we ever seen
Right.
a cycle size 12? Yes, we have. 14,
yes.
16. Okay, so we do see all these cycles. Okay, fine. Fine. Okay, so now let's try to understand what the characteristics of those cycles are. Do you understand what I'm saying?
Mm-hmm.
So we should be able to get that from here, right? So what feature do these things have in common? There are a Fibonacci number of them, right? How do we get, and we know that whenever we have 0, 1 sequences, and so the number of these is 3, right? And so these are of length 6, okay? So if we just look at wherever it is, okay, so here I think we're going to see something interesting. Okay, so take a look at this.
Let me for the
I,
8 case, let me call your attention to something.
Yeah. Okay.
Look at the last one.
Yeah. Yeah.
You see that's a simple pattern, and look at the first one of length 8.
Yeah, I see it. Right, and look at these ones here.
That's always, that always happens.
No, but look at this one. That isn't like that. This one here is like that. Right. So look, here's what we're going to see. right? These are length 8, right? So really, that's a length. Okay. The length 8 one is really a length 3 object with respect to the Fibonacci, no pair of identical things together, right? So here's what I think is going to happen. So I think that thing there, it's really length 3. That means these are broken into blocks of some kind. Do you understand what I'm saying?
Uh-huh.
And my guess would be that those blocks, so these blocks, so this is length 8, it's really of length 3. So how would we break this into 3 tuples, right? So I think that these are, I'm going to guess that it's 0, 0, 0, 1. What is it? I'm forgetting the recurrence. 1, 1, 0, 1, right? That's the thing that gets added, right? Do you understand what I'm saying?
Right.
So
Uh-huh.
if we were to assume, is it the case that these can always be decomposed? No, they can't. Look at that. 1, 1, 1, 0, 0, 1. So they're not always compositions of these. Do you see what I'm saying?
Right. But their expansions are.
What expansions? I know, but the expansions
If you
obviously
do
are.
this,
I understand, but the expansions will always
mhm,
be of anything that gets consumed, right?
yes. Hmm.
Right. So that's uninteresting. So this, okay. So what we're looking at here. Okay. So the last of these is a 0, 1, 0, 1, 0, 1, whatever. By the way, are these distinct cycles? Are these,
Right.
is this a single cycle or are these distinct cycles? Do you understand my question?
I didn't check that. Yes, I didn't check that. They
Okay.
could well lead into each other.
Let's check that. Okay. So let's look at these and let's say, so let's see, what do we want to do? I want to say for each of these, I want to give the successor states, right?
Mhm.
And that is given by taking hash goes to, well, I mean, I just want a nest graph, don't I, starting from these, but I want hash goes to, how do I generate the things up here? How do I generate these? TS all inits, nest graph. What the hell? Oh, these are compressed.
Right.
Okay, so I want the corresponding thing. Do I want the corresponding thing for the what do I want to do? I could do a from whatchamajigamy.
You could just uncompress them with the expansion.
Yes, but then I've got blanks in them. Then they won't make cycles.
No, not with use the 0 goes to 0, 0, 1 goes to 1, 1, 0, 1 and flatten. And that will change all of these to uncompressed form.
Okay, all right.
Uh-huh. So there's 2 different cycles. Well, 3. And that's the length 10 case.
Yeah, okay, so let's go 2 to 14 steps of 2. And for each of those, oh, I see. Let's go 100 steps just for good measure.
Cool.
Well, but these are subcycles, right?
Mm-hmm.
Those are the factors.
Mm-hmm.
All right. So actually, these Fibonacci numbers are sort of irrelevant because they're just the sum. I think they're the sum of the factors, aren't they? Whereas,
I don't know.
well, look what has to be happening, right? Because this is 6. No.
That's 4.
How can that be right? Look, how many distinct... Which ones are starting states here? You see, look, if I go here and I say table of length of that select, okay, 1, 2, 3, 5, 8. Okay, so 1, 2, 3. What does that mean? Okay, so what we need to do here is we need to highlight the initial thingy dingies, right?
Or just
Here,
highlight the
here.
ones that have a length divisible by
Uh,
3.
okay, hold on. That's pretty weird. See that?
Uh-huh.
How do you make those things bigger? Those dots bigger? Highlights.
I'm not sure. 5. Well, that's cool.
What? What are you seeing here?
Oh, the fact just the way these are interplaying with each other is somewhat interesting.
Well, these, why is there no 5 cycle here? Okay, that's a 6 cycle. There's no 3 cycle, right?
Correct. All cycles have even length so far.
What do you mean by so far? I bet that's
well, we've gone up to 646 bits and haven't found any counterexamples, but I'm pretty sure that that's the case.
okay. But look at these. Okay, so these are the cycles.
And the 2 cycle is always the 0, 1 case.
Okay.
You should put another 1 at the end.
Okay. All right. So thing to understand, which maybe you could try to understand, is why, but this is basically a classification of all the cycles, right? And every cycle here is distinct,
Right.
right? So this means there's a length 2 cycle that has, you know, 2 elements in it, 4 elements, 6, 8, etc., right?
Right. Mm-hmm.
And for every, okay, so in other words, i.e., there is a cycle of length 2 tau, no, 2 p for every p, and a and the length in bits of the sequence leading to that cycle can be, now what are we saying? Can be any, for any k less than or equal to p. Is that true? Or is it greater than or equal to p? Do you understand what I'm saying?
Yes. Well, it's the cycles will be even divisors.
That's not true. Look at that case there.
Right, that's 8, and the even divisors are 4 and 2.
I see. This one is 12. Okay. And the length and bits of the sequence leading to that cycle, associated with that cycle, can be any even divisor of 2p, right?
Mm-hmm. I'm not sure why you're using p. Usually that means a prime number. I would
Okay.
use n instead.
I don't want to use n. I want to use something else. I want to use w.
Okay, that's fine.
Okay, an even divisor of that, or it can be 2 times the divisor of w, right? That's equivalent, correct?
Yes. Mm-hmm. Mm-hmm.
Okay. Okay. So, all right, so this is the cycle structure. Now, if we look up here at our cycle structure, we're seeing a bunch of 1 cycles, which we don't really normally get. I don't understand what these are. What's surprising here is that we don't get all of these 2 cycles, whatever. This is up to length 6. Sort of surprising the ordering in which we get these cycles. And also we get this bizarre phenomenon of these freeway things with on-ramps.
So one question is, how do you brute force up to 2 to the 46?
To do what? To find out what do you mean? For what purpose?
Define how do you find all cycles up to 46 bits?
But this is all cycles. This is going to give us all cycles, right?
Yes, but 2 to the 46 is a large number.
I don't care. I don't care. This algorithm that we've got here. Oh, I see. You're saying, well, I know, but that's why we've got. But Ed, that's why we've got to find out what the actual structure of these cycles is, right? What are the
right?
Okay.
So obviously, I figured out something.
What was that? What was the point of that? Yes. Ed?
And the way you find those is you also keep the ones that are out of phase, and once you've established that, okay, here's something that can generate itself, you don't have to look at things that don't generate themselves because they won't start such a list. So at that point, you can just run extensions to everything. And that's how you grow everything up to size 46.
I'm confused. So you're saying if I look at these, right, these are the seeds.
Yes.
Right?
Exactly.
These are the seeds. Okay, so these are
well those aren't the complete list of seeds.
Yes, they are.
You'd also want
what?
You'd also want the ones that are out of phase, because the ones that are out of phase could possibly lead to cycles once you extend them.
But don't you know that that isn't the case?
No, an out of phase one, if you add enough ones and zeros, it's possible that it will become something in phase again.
Okay, so we
that
need
also
to prove
generates itself.
Okay. So Ed, this procedure is not necessarily exhaustive, but we need you to prove that it is exhaustive. You see what I'm saying?
Mm-hmm.
Now, but here you made a different statement, which I think is interesting, which is to use a recursion relation to get these successive things, right? Let's look at that, okay? So we're going to look at these, and we're going to ask the question, what is the recursion that gets from one to the next? Okay, so we got 0, 1 there. What are we doing to get to this? See here, it's like we append 0, 1. That's one of the things we can do.
Right. Mm-hmm. Mm-hmm.
This is the append of 0, 1 to that. Oh,
right.
This is a Fibonacci word thing. Okay, so what we're going to do is Oh, look, oh, look, oh, look. Well, okay, so let's say, okay, so the given a set of things, we can either, you know, cycle recurse.
Oh, 0, 1, and 1, 0 have a 0 phase, so it could be added to the start or end.
Okay. Okay, well, let's just look at how this recurses, okay? So one thing we can do is we say append, join hash 01 /@ cycles. Okay, so that gives the thing that is the same number as the previous number of as the cycles, okay? So what I'm predicting is that what's going to happen is that's the same number of cycles, you see, and I think what it's going to be is fn is fn minus 1, same number of cycles with 0, 1 added to them, plus something that's the -2 case. You see what I'm saying? That's something added to
Yes.
the -2 case. So here, we've added 0, 1. Well, let's look at this case here, okay? We've added 0, 1. Let's look at each of these. We've added 0, 1 to that one. We've added 0, 1 to that one. And then this one here, what is that guy there? See what I'm saying?
You added 0, 1 to the start. You added 0, 1 to the start.
But only to one of the previous things.
Right.
So I think that's coming from there, because that would give us a Fibonacci number.
Uh-huh.
So how did it get from there? Well, maybe what happened is this 0, 1 is actually added to the start. Maybe there's 2 0, 1s added to the start here. How do we get to this one?
Okay.
Okay.
You add 0, 1 to the start.
Okay, so hold on. So what we're doing is we're adding, okay, so let's go cycle recurse of, well, no, what we want to do is, you know, cycle inventory. How do we do this? No, we want to say cycle recurse of CR1 back and CR2 back. Okay?
Okay.
So that is potentially join 0, 1 to cycle 1 back. Yes?
Mm-hmm.
And what else is it? Actually, it's not just to the cycle, it's join that to every one of those. Right?
Right.
So I'm saying join that to every one of those. Mm-hmm. Okay, now everyone that's 1 back. Did you understand what I'm saying? So then what do we do? So that's the first thing we do. To everyone that's 1 back, we join 0, 1. Okay, so that gives us, in this case, these 2.
Uh-huh.
Okay. Then what are we doing to get this one?
Adding 0, 1 to the end.
No, we're not. Because that's adding 0, 1 to the end of something 1 back, which is not going to give us Fibonacci numbers.
Okay.
So what if we prepended 1, 1, 0, 0? I mean, I have no idea why that's correct, but we could just try it. I don't think that's right. Look at these. Well, let's just try it. Okay, so C-rec of this, that's the one back guy. And this, that's the two back one. Okay, so that gives us correctly, is that right? That's giving us correctly this one here, right? So the next recursion would
Yeah,
be,
that all looks correct.
well, that one was trivially correct because we constructed it that way. That's the one back thing, and that's the two back thing. Okay, so let's just sort this. And then that is to be compared with this thing here. Let's try sorting this.
Mm-hmm.
What do you
They
know?
look remarkably similar.
The puppy is alive. Okay, so well, should we go on? Let's see whether this will.
Yeah, let's see if the next one works.
Okay, so then the way we want to do this, we can do, can we do a nest list here?
Well, let's just try the next one, and that's enough to convince me if the next one works.
Okay, all right, here. That's this one here. Okay, so what's that one? That's this one here, right? Is that right?
No, you want to go back.
This one here.
Yeah.
Okay. Well, there we have
Yeah,
it.
looks like you've got it.
Okay.
No, I had something much more complicated.
Well, I'm an old and wizened hunter.
Yeah, I sent you a note that there's probably an extremely clever piece of code that generates all cycles, and you just found it.
Yeah. Brilliant. Okay. 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 So we have that. So there are Fibonacci many seeds. So the number of distinct cycles. Okay, so this is basically telling us how the cycles work. Okay, I want to understand the freeways, and then we should look at. I've got a fair inventory of really big ones, and we can look at those. But do you understand the freeways? Do you understand what's happening when it goes onto a freeway? Do you understand what I'm asking?
Well, sort of, because we've looked at them, but I don't understand quite how the chaos within them works.
What do you mean by that? I mean, the freeway, what I'm saying is there's an on-ramp, right?
Mm-hmm.
And the point is, once you're on a freeway, so what I found is that for these big cases, okay, it's incredibly common if you just randomly pick things, right, that they'll end up on the same freeway.
Okay. Okay.
Right. So that's really, really common to end up on the same freeway. Right. So the question is, what's the catchment area for a typical freeway? Right. Given a freeway. Okay. Freeways.
Well, one thing when I found this Fibonacci thing, one thing I suspected is that there is some sort of Fibonacci analysis that could be done on a given item, and that would tell you how long it took to get to one of these Fibonacci cycles. I'm not sure if that's true, but it would be amazing if it was true.
Yeah, I don't think it's true. I mean, it may be that the thing is Fibonacci has a kind of Fibonacci character to it, but given a long freeway, okay, what feeds into the freeway? Or is it mostly the freeway itself? Do you understand what I'm saying?
Mm-hmm.
If the sequences in the freeway get big, it has to be the early part of the freeway. That is its feeder. You see what I'm saying?
Okay.
Right?
Uh-huh.
Because otherwise it wouldn't ever be found. Right? So here,
Right.
if I look at this, okay, so let's look at, okay, so let's have a section on freeways here. Okay, so this freeway, we're saying, well, let's look at the freeway. Any of these freeways. So, I mean, let's, I don't know what this one, but I mean, this one here is, how do we get the big component of this? We simply say, I think we did this already. We just say graph, oh, largest components. Here we go. Okay, so these are the largest components, right?
Mm-hmm.
Largest components. I'm confused by this. Why isn't this the freeway length? And how come? Oh, I see. This is the logarithmic scale. Right.
Right. Uh-huh.
Right. All right. So there's a pretty good fit here. Which I bet is given in terms of, yeah, so let's look at the fit here. Okay, so let's look at the ratios here. That's weird. Wow, that's really weird. Okay, so those are freeway lengths. That's interesting. So the freeway length ratios versus initial size, right? Wiggles around all over the place.
Mm-hmm. One thing I've been curious about is which cycles have a generator that's smaller than the cycle if it follows a highway. For example, you've got on that long highway, you've got a 28 cycle at the end, but the generator is much smaller.
Yeah, but everything ends in a cycle, so far as we know.
Right. But I'm all curious for the smallest generator that eventually leads into cycle.
Yeah, I mean, we can look at that, but I think, okay, all right, let's look at this. The next thing to look at, I think, is, for example, for the champion, right? This champion. Okay, let's see what it does at the end.
Mm-hmm.
Okay, so what? How do we do that with Max's code? What do we do?
I don't remember. It's almost 1 in the morning, or no, past over there.
Okay, let's see. Post tag final system final state of this,
That sounds right.
and then let's say 21 million. Really? So that tells us that this goes to the state with all zeros. So if we now take that, how do we evolve that when we say max to SW?
Oh, that's not going to do anything.
Well, but is it a cycle?
No,
This,
all zeros is not a cycle.
well, what is it? What does it do? What does it do? What does it evolve to?
It dies.
Okay, well, why didn't it already die here? We evolved it to 21
I'm
million
not
steps.
sure.
Right. So the question is at 21 million and 8 steps. Oh, okay. So what the hell? At 21 million and 8 steps, it's still that. I think max.
Right, I tried 10
handle
million steps.
10 million steps will be something absolutely giant. Okay, so we need to understand from max. That's another thing. Maybe you can look at the GitHub comments and things here.
Okay.
I mean, okay, so let's start a couple of runs. So I mean, basically what we're finding is, okay, the main point is that this is of length 15, but the whole point is 2 to the 15 is only that. So the length of the freeway is long compared to the number of, yeah, this is what we want to do. This is what we want to do. Look, okay, the length of the freeway is long compared to the number of possible distinct inputs. Okay, so what we want to do, I see what to do. Where is my evolution thing? The thing that I was doing that is the analog of this. This is what is it called? TS mod evolve. Okay, so we want a TS mod evolve list Okay, so here's what we want to do. TPS Mod evolve list of this, comma 0, right? That thing there, and let's say 100 steps.
Mm-hmm.
Okay, so
Right.
that's generating all kinds of random gunkasaurs. Okay. Now what we want to do is we want to say length of first of hash. That's interesting. So the number of things that are of length on the order of 15 is not very large. So most of the course of the
Right.
freeway is big, right? So the question is, why is there a bushy tail? Why does it have a bushy tail that pulls in a lot of stuff? You see what I'm saying? Why does a lot evolve to that something on the freeway? Right? So something has a lot of pre-images. Right? So the question is, in a case like this, we want to find the states that have a large in degree. You see what I'm saying?
Mm-hmm. Uh-huh.
Okay, so if we say this nest graph, okay, so let's say, okay, so now let's say vertex in degree of ng, and say take largest percent comma 10. What? Let's do counts. Percent 1425. Oh boy. So some of these things are trees, basically.
Mm-hmm.
That
Yes.
has to be what happens. So how do you find the oh, it's the in component, right? It's the vertex in component, if I'm not mistaken.
I think so. Mm-hmm.
Okay. All right. Vertex in component of ng. Oh, really? Well, I'm going to prepare to say infinity here.
No, I just found out I'm going to be on National Public Radio tomorrow.
Oh, cool. About what?
One of my puzzles was selected for the on-air puzzle.
Very cool. What's it about?
Take somebody recently in the news, say his name with the first initial and last name, and you'll name a famous American. Who's the person in the news?
Oh, for God's sake, I can't do those.
It's Abe Lincoln, the current Secretary of State, who sounds like Abe Lincoln.
Oh, oh, wow. Okay. Uh, well, to each their own. It's fun. That's fun. All right, so this allows you to say the in component for a given vertex. How do you get the size of the, does in degree allow you to specify? Let's see, what we want to do is we want to find the in component for every, we want to find the size. We want to say vertex. What does in component actually return? ng1 or something. Oops. That took a surprisingly long time to find that vertex in component.
Mm-hmm.
So what we're looking for is the length of the vertex in component of ng comma hash But wait a second. I just have to look at a given weakly connected component, right?
Right.
How do I find the in components? Do you understand what I'm saying?
I think so.
Right. I want to find the in components. Okay, so here I want to take this and I want to take that n equals 5 or something. Okay. And now I'm going to say, oh God. Okay, so there, that's the graph. And I'm going to say here, I want the subgraph that is, I want subgraph of ng that is the first of the weakly connected components of ng. Actually, if I just said weakly connected, I just say first of weakly connected graph components. Is that right? Weakly connected graph components? Yeah. I think I would get that graph.
Mm-hmm.
Okay, there we go. There's the graph. Okay, so for that graph, I'm asking,
Pruning.
how do I do that? I'm trying to get, how do I get the
The trunk of the tree.
of the elephant? Right, how do I get the trunk? But how do I get the stuff that is feeding into the trunk? Right, so I think what I want to say is I want to say vertex in component of, let's call this fng. Okay, vertex in component of, I want the length of the vertex in component of fn.
Well, the in and out need to total 2 or more than 2.
Why? The in component, look.
It's a directed graph.
Okay, so there's a bit of tentacles at the end. Let's not worry about the tentacles at the end.
Okay. Okay.
Um, okay, so
That doesn't
that's,
seem right.
why not? Okay, let's do this. Let's take fng and let's say vertex graph of fng, vertex size goes to hash arrow length of vertex That's not so stupid. Look at that.
Mm-hmm.
Um,
Try dividing by 100 or something. Yeah. Okay. Mm-hmm. Oh, yeah. Okay.
So basically what's happening is that's the head of the animal, right? So it's going into there.
Uh-huh.
So everything's going towards the head of the animal. It's got a very long tail.
Right.
Okay, so what does this tell us? This tells us most of the time the trunk vertex in component. So these ones here could be feeding. Oh, I see. These will not feed into anything long. These are not feeding into a freeway. The only ones feeding into a freeway are the ones out in the tail out here, right?
Oh, okay.
Right?
I think so.
Yeah, I think so. And then this is gradually accumulating, right? It's gradually accumulating things.
Is there a graph output that's like spiral? I think so.
Yeah, I think there is. Discrete spiral embedding. Spiral embedding.
Yeah.
I don't know why that's useful. Why is that useful?
Well, that's kind of cool.
What does that show us?
Yeah, it's not that useful, but it is more compact.
I know. I like to see these freeways. Okay, so this is telling us let's see, what? Okay, the real question is, everything is eventually going to this state here. Okay, to the 469 state. So it's lost a vertex list. Yes, look at this. Look what we're going to be able to figure out. Lost a vertex list of FNG. That's really weird. Okay. Okay, so that is vertex 1 seems to be the end of the animal. Okay. So then the question is, how many vertices are how far away from vertex 1? Okay. So graph distance of hash comma 1, of FNG hash comma 1, that mapped over vertex list of FNG. So that's telling us okay, so let's look at that histogram. I see. So that's basically telling us most are on the freeway because they're just increasing, right? Just by virtue of
Let's
yeah, see there
add
it is. That's the freeway.
hash. Let's add hash and figure out which vertex is the maximal.
Maximal what? Distance?
So it would be that you'd be right.
But you see, what this is showing is most vertices are just accumulating their distance from the root. Right? They're just adding into the freeway.
Yes.
And that's showing that there are some number of vertices that are very close. I mean, this is those vertices there are part of the feeder for the freeway.
Right.
What's sort of surprising is that so many things look like they're the same freeway. Because it means that, well, it means that everything we're seeing is in that bushy tail there. You see?
Right. Uh-huh.
So the question is, how can we find the size of the tail? What we want to do is we want to find those nodes that are more or less a freeway length away from the final sink.
Mm-hmm.
We want to find the antipode of the final sink somehow. But okay, we need to wrap up in a moment. But I just want to look at one thing that okay, I did a big run, big long overnight run. Okay, and I generated a whole bunch of things here. These are all ones that survived. Let's see how long they survived. Two to the 20th times 5,000. Oh my gosh, they survived 5 billion steps.
Wow.
Okay. So the question is, how long will they survive? Right. So if I pick one of these, I don't know where I want to go, maybe one here, then I can say, actually, I probably can do one of my visualizations. I lost the head of my mouse. Okay, so that was the size. That thing survived about 3 billion steps.
Mm-hmm.
Okay, so this is the first one that survived 5 billion steps.
Oh, wow. Okay.
But it's not exhaustive. See, let's see, 10 million.
I looked at that Fibonacci thing for hours and you solved it in minutes.
Yeah, well,
I'm very impressed.
fair enough. Well, but I couldn't solve most of your puzzles.
I mean, well, I am an expert on these things.
Yeah, that's true. That's true. So I should feel better about it. Anyway, okay, so let's just look for this guy. But the thing is, I don't really think there's anything other than to just look. I mean, so one thing that I predict is going to happen is that if we look at these at successively greater lengths, many of them will be the same freeways over and over again.
Mm-hmm.
And we probably can recognize that. So that means, okay, there's really two cases. If we understood why that was happening, then we would know whether random searches was sufficient or whether there could be like a golf course where everything is flat and then there's just one hole. You see what I'm saying?
Right, right.
Just wait for this to come back and then we'll wrap it up. I mean, but so that's the question is I don't yet understand why there are these freeways. Do you see why? Can you think why there would be anything like this? So, I mean, in other words, what's happening is as soon as the thing gets big,
Well, one thing I've wanted to do is start with a cycle and try to.
look, Ed, there's something pretty obvious here. Okay. The reason there's a freeway, actually, it's really obvious. There is a freeway because as soon as the intermediates get big, they will not have incoming trees from the sizes we've looked at. Okay, so what could have
Right.
happened is there could be an intermediate
You
coming
can
in.
you can see that on the notebook underneath. You have a freeway for 10 with the up to 5, but that 10 is part of a more complicated tree in the next case.
Oh, very good point. Woof. That's a good point. Okay, so
Of
basically,
course, we'd want to check that they're the same 10 cycle though.
well, they have to be because this is up to 6. It's got to be the same 10 cycle. There's no other 10 cycle. Can't fail to be.
Okay. Oh, actually, didn't we determine there's 2 10 cycles?
There may be, but we're not reaching the 10 cycle here because to reach a 10 cycle, you need to have an initial condition which is essentially 30 long.
Okay.
Right? Okay, but it bushes out in the 6 in its case. So basically, what starts as a freeway, in other words, the first time you reach a freeway, it's not bushy.
Uh-huh.
Last time you reach a freeway with the smallest init that does it, it's not bushy. But somehow it gets bushy as you get bigger. But the issue is, yeah, it's not obvious to me that you have to have freeways. I mean, that just doesn't seem obvious. Oh, wow, what the hell? Well, that's really boring. It dies by... Okay, let's see. What? How can that be? Something's gone very wrong here.
I don't know.
What the heck? Okay, well, let's go to 2000 here. Okay, so that was at 10 million. So 1500 times 10 million is otherwise known as 15 billion. Okay, so that puppy
Yes.
survives for 15 billion steps.
Oh, nice.
What the heck does this mean? These are perfect random walks. Their probability of surviving. So I got help from child number 2 with this question of the survival time of random walks. Oops. Okay, so she claims yeah, there we go. It's the probability. What's the probability that lasts greater than a time u is this Earth? That's the claim. So
Oh, I just thought of something.
yeah.
For a given bit length, we know how many cycles there are of that length.
Okay. So
So it's some sort of 2 to the n over Fibonacci n correspondence for the probability that a random walk will end for these.
say that again.
It's something like 2 to the n over Fibonacci n for when a random walk will end.
I don't understand that. What do you mean when a random walk will end? I mean, this is saying that the
This is-
probability that the distribution, this is saying the probability to reach size u. So like our probability. Okay, so here let me give you an example. Okay, so with this estimate, probability to reach size 15 billion there. 15 billion is 6.5 times 10 to the minus 6. And what
Okay.
we've observed, okay, what we've observed is that at length 56, what is that init there? Oh, I see. That's a phase 0 init. So at length 56. So that first happens at length 56. So what's the log to the base 2 of that? 17. Why is that? Wait a minute. Is that multiplied by 3? I don't know whether my length 56 is R. Oh, I think, yeah, it's like multiplied by 3.
Okay.
Is it? I'm not sure. I'm not sure. I'm not sure. So this is giving an estimate for when I expect to have a random walk, which will last that long.
Okay.
What the probability of finding such a random walk is. Again, we need to line all these up. But that, let's say it's the case. Boy, this is weird. This is really weird. That the probability to get a random walk that lasts a given length is correctly. What does this mean in terms of, it's just really weird. What does this mean if for any length with a certain probability, I can get wow, it's really weird. It's kind of feeding probabilities into Do you get what I'm saying? What do you think the analogous thing in the 3n+1 problem is? Because this is the same. I mean, what are the stopping times of the 3n+1 problem? Are they interesting? Are they long? They're not very long, are they?
Not usually.
Right.
This is perhaps a harder case though, because you've got an infinite number of cycles.
Yes.
And we can prove that just by considering prime numbers times 2.
Well, these are the total stopping times. This is for the Collatz problem. This is nothing.
Okay.
They're like logarithmic.
Mm-hmm.
I think they have a yeah. Yeah, I mean, they tend to be sort of logarithmic, I think. Well, let's see what the estimate of the stopping time is. Yeah, 10 to the 17, it's 2,000 steps.
Okay.
Yeah, here we go. So this is, the Collatz problem is a very tree-like problem. It does not have freeways.
Mm-hmm.
I mean, I'm sure we can just write nest graph of, let's see, we just start off, don't we, we just say if even q hash,
Jesse Nochala had really good code.
okay. Well, we
It's in
can,
demonstrations.
oh, I see, we should just look at that. But I mean, we can make this graph, right, range 100, for example, and we can say 100 steps here, for example. No,
Mm-hmm.
200, 100 steps. Oh, that has a long freeway. Wow, that's really weird. That's surprising. Let's go 200 steps here. Doesn't make any difference. Wow, that's kind of surprising, isn't it?
Uh-huh.
But these stopping times are very, very short compared to 1,000, so to speak.
Right. Looks like the same thing.
Yeah, I think so. Where's the demonstrations project? Collatz paths. Oh, that's nice.
Mm-hmm.
It's actually something we should do with ours. With them. That's actually a good idea, layered embedding.
Mm-hmm.
Something we should do up here. At least this guy here. my God, what is it doing? No, don't tell me my kernel is crashing after 1500 inputs. Oh, that's really upsetting. I've been running this kernel for a week. That crashed it.
Okay. Okay.
My God, why is this so hard?
Might be because there's multiple graphs.
Hmm. It crashed again. Well, try and tell me something. Anyway, so it's very different. Oh, I see. This is going up to the top, right?
Mm-hmm. Right.
Wow, what on earth? Oh, here we go.
Well, that's complicated.
But this is, it's very tree-y.
Yes.
Very different character of thing.
Yes.
I mean, there's a fairly long tentacle there,
Right.
but it's still short compared to. Yeah, I mean, obviously, it can get larger, but it's going to. Yeah. But the question is, what the heck does it mean that these things are really close to random walks? What does that mean? You know, computation theoretically, how could it be the case that uh,
Well, it's basically a sort algorithm of some sort that's really, really bad.
why are you saying that?
Because it's basically moving things around and trying to find a structure that ultimately becomes a Fibonacci-based sequence, but it just can take a really, really long time to get there.
I see. Yeah, but it's also this tag idea. It's the head's got to reach the tail.
Mm-hmm.
How long does the head take to reach the tail?
Oh, no, it doesn't have to. It basically just needs to find a Fibonacci sequence.
I
It
see.
can stop when it hits a cycle.
Yeah, right. That's a good point. It doesn't actually need to catch up with the tail.
It just needs to sort it in a Fibonacci-like order. And it's really bad at it.
I understand, but what does that mean? I mean, is it like a halting problem? What's the halting probability? I mean, what's the halting time distribution? But the question is, what if you could never prove? Oh, boy, this is so weird. There's got to be a way of formulating this question so that, I mean, clearly, if you have something which just always increases, right, you could find a glider gun.
Right. So we can rule out one stage glider guns at this point.
Okay.
But there might be a two-stage glider gun. I still haven't figured out how to code that properly yet.
Okay. I need to figure that out. But I mean, my question is, once you exhibit a glider gun, you're done. You've proved that it doesn't terminate. Right?
Mm-hmm. Yes.
So that means it's a problem. Let's see. I mean, right now, the halting probability for this system appears to be 1. Right? It is
Yes.
deterministic. It appears to always halt. But the fact that it takes an arbitrarily long time to halt reminds me of a bunch of these Goodstein sequences and so on. You know, when in doubt,
For these random cases you're trying, what sizes are you trying?
56, length 56 was the one that had this 5 billion case. But I went up to, I was doing them in steps of 8.
Okay. And say length 24 didn't show anything spectacular?
No.
Okay.
Okay, so this is the Goodstein sequence. Certain sequences are of limited length for all n. Okay, so it grows too quickly for its finiteness to be provable in pure arithmetic.
Yeah, we don't have that problem.
What?
It's growing too much.
No. I mean, this sequence, this is a termination problem for sequences.
Oh, I see. Okay.
I don't really, this is usually tack up. Basic idea is to set up a correspondence between the elements of G of n and possible proofs in pure arithmetic. Oh. This is a good explanation. This is really good compared to other things I've seen of this. Oh, wow.
Oh, I thought of another question we need to prove.
Yeah.
Are all cycles Fibonacci?
Right.
So for these big runs you're doing, you should send the cycle back if it's once it's been established.
I do. I think I do.
Okay.
But I don't know whether Max's code is validly giving the cycles.
That would be a good thing to check, and then we could
Yeah, I know.
we could
Maybe you can
see
ask
if
Max.
all the
Right. Right. So that's a question. Are all cycles Fibonacci? Do you understand how this proof works? What this is saying is that you make this thing, you show that this thing corresponds to a valid proof. You go meta-mathematical with it. So what you're doing is you're saying this thing is representing a proof. And if it was the case that all sequences terminated, then all proofs are valid.
Okay.
And the claim is that that would prove, if you can show that, so you can think of this thing as being a proof. And so if it always terminates, the idea would be to show that that corresponds to, yeah, it's kind of clever actually. I mean, it's showing that if all proofs terminate, then that proves, if you know that all proofs terminate, let's see, what does it prove? All proofs terminate in such and such a thing. Then the claim is that that proves the consistency of arithmetic. In other words, proves the consistency of whatever axiom system is encoded in, whatever axiom system has its proofs encoded in these transformations. That this then proves the consistency of that axiom system if all of them terminate.
Okay.
It proves the citability of that axiom system. I'm actually a little confused by that. It proves, it's a proof of decidability. To say that they all terminate is a proof of decidability. And the claim is that that can't be established, I see, from the end within the axiom system that represents. And so that is then, if you can show that you can encode all these things in that axiom system, right, then it shows. It's kind of wild because, again, there's a sequence, a concrete sequence, where you can't prove that it terminates in Peano arithmetic, but you can prove it terminates in set theory. Isn't that kind of wild?
Okay. Okay.
So the question is could something like that be going on?
So let's see.
What's that?
One thing in your random checker is, does it generate a cycle whose length is greater than the length of the parts of the cycle?
Okay, you're going to have to formulate this. We should talk about this again tomorrow or so. I need to go. You need to go. Sorry to keep you up so late, but
That's fine.
We're on a hunt. We're on a hunt. We're finding, you know, well.
Congratulations on finding that clever piece of code.
Right. Well,
I would not have found that.
Right.
I feel ashamed.
Well, it's okay. I'm a old and wizened hunter, as I said.
Yes.
It doesn't super surprise me. I mean, look, by the time you know it's a Fibonacci thing, you know it has to be. I mean, you know, it has to be some kind of recurrence like that, because. Anyway.
Yes, I was trying something more complicated.
Right.
Anyways.
Yeah,
Talk to
okay,
you
sounds
soon.
good. Okay, see you sometime tomorrow. Okay, okay, bye.
All right,
Thanks.
bye.
Bye.